Hi there, and welcome to today's class. For today's class, we're talking about the concept of multiplication of vector. So, how do you multiply vector? Before we dive into the concept of multiplication of vector, note that when it comes to multiplying two vector, there are about two ways of multiplying vector. There are two distinct ways of multiplying vector. Number one, we have what we call the scalar. So we have the scalar or the scalar, or you call it dot product of vector. The first way of this is the same. This is the first way of multiplying two vector. Number one is what? Scalar or dot product of vector. Number two, the second way of multiplying two vector is what we call the vector or cross product of vector. So these are the two ways in which we can multiply vectors. So we have the scalar, or you call it dot product of vector. We have the vector, or you call it cross product of vector. So for this class, we'll be dealing majorly on the first one called scalar or dot product of vector. So let's start with the first one. They're called scalar or dot product of vector. So there are about two ways. Let's start with the first one called scalar or dot product of vector. When it comes to scalar or dot product of vector, how do you multiply vector? So given vector A and B, given a vector A and vector B, a vector A, given a vector A and vector B, given a vector A and vector B such that they are multiplying. So their dot product is written as a vector A dot vector B. So given two vector A and B, note that their dot product is written as a vector A dot vector B. So let's say I'm given vector A to be equal to AXI plus AYJ plus AZK. And I'm giving vector B to be equal to BXI plus BYJ plus BZK. Now, when it comes to the mathematical expression for dot product, so let's say I'm giving a vector A and B as this. Their dot product, so A dot B, the mathematical expression mathematically A dot B, the product of these two vectors A dot B is equal to AX times BX. I have AX multiply BX plus AY multiply BY, AY multiply BY plus AZ multiply BZ, AZ multiply BZ. This is simply the mathematical expression for dot product of vector. So we're told to multiply two vector, simply multiply the coordinate of I with the coordinate of I of the second vector, add it up with the coordinate of, multiply the coordinate of J for the first vector and second vector, add them up with, multiply the coordinate of K, which is AZ and BZ. So let's prove this one here. Prove. Why is it that if I multiply two vector, I'll have this expression? Let's prove it. Prove. Let's prove this concept here. Now, when it comes to proving this concept here, so to prove this concept is quite simple. Note the following. Note that I is equal to I, which is equal to K is equal to k, right? Equal to j, which is equal to 1, or perhaps, sorry. To prove this concept here is what you need to note. Note that note that I dot I is equal to k dot k is equal to j dot j, which is equal to 1. So when it comes to proving this man here, note that I dot I is equal to j dot k dot j is equal to j dot j, which is equal to 1. At this point here, what's the next task? We're multiplying these two. So I'm saying that vector A is multiplying vector B, which is expressed as everything here, all the elements in vector A includes AXI plus AYJ plus AZK. So this one here is multiplying vector B, which is include BXI plus BYJ plus BZK. So let's multiply these two vectors. Start with the first one here. This one, I'll use this one here to expand everything here. So I'll have the first one, AXI. So look up, please. Look up. Let's start with this way. AXI multiply BXI. I'll have AX next up, BX, I have I, yeah. So take them together this way, right? Or perhaps I dot I, like they are multiplying. So AX multiply BX, I have AX BX, I multiply I is in this case here, plus AXI multiply BYJ. I'll have AX first before BY. Next I'm seeing I and J. So I and J are combining. Next up, multiply this one with this. I'll have plus AX multiplied by BZ into what? I dot K. I'm done with this one here. Pick out the second one here, which is this. That's plus multiply this one, AY times BX. I just pick AY and BX. J and I are combining. So I have J and I, right? Next up, I'm done with this one. Using this to multiply this. Using it to multiply this one now, I'll have plus AY multiply BY. I'll have AY BY into, this is J multiplying J. Next up, I'll use this AY to multiply BZ. So I'll have plus AY, next up, BZ into, this is J multiplying K. At this point here, my next task now is that since I've used this one to multiply everything, I'll now take this one to multiply everything here. So I'm having plus AZK times BSI. I'll have AZ, next up, BX into, this is K and I. I'll have K dot I. Next up, plus, I'll have a plus sign here. I'm done using this one to multiply this. Use this to multiply this one. I'll have AZ times BZ, sorry, BY, AZ times BY into K dot J. I have K dot J. Use to multiply this one. Finally, I'll have plus AZ multiplying BZ. So this is into K dot K, as you can see. So what we said earlier, that we said whenever I'm having I dot I, they are the same, and K dot K, they are the same thing. J dot J, I'll have 1. So it means that if there's a mix up, like you look at this one now. All right, looking at this one now, I'm having I, this is 1. I'm having IJ, this is 0. So it must be of the same thing. So look at this one. This one becomes 0. This one becomes 0 because they're not the same thing. This one becomes 0. So this becomes 1, yeah? This exists, 1. JJ. Look at this one. This one becomes 0. This one becomes 0. Right? That's off. This one is 0 is off. So I'm left with what? 1, 2, and 3. So it means that the dot product of A dot B, if this two vector multiply, I'll have what? AX, BX, I dot I will give 1. So it's off. Plus AY, BY, BY. So J dot J will give 1. So it's off. Plus AZ, BZ. K plus K times K or K dot K will give 1. So this is becomes what I have here as a mathematical expression for the dot product of this vector here. Before using this to solve some problem, let's look at something important. Dot product in terms of angle. So dot product in terms of angle What's the concept when it comes to dot product in terms of angle? What do we need to know? So here's what you need to note. Note that if two vectors multiply in terms of angle, right? We said so. Given two vector A and vector B, so they're multiplying. So if they're multiplying, I'll have A dot B. So in terms of angle, is equal to the magnitude of A dot the magnitude of B cos theta. So to express the dot product of two vectors, the concept is multiply the magnitude of each vector cos theta. At this point here, I want to make theta subject. So make theta subject. So I'll divide through here by what? So I'll divide through by the magnitude of A and magnitude of B. So I'll have dot product of A and B, observe, is equal to the magnitude of A dot the magnitude of B cos theta all over the magnitude of A dot the magnitude of B. So all over, divide through by the magnitude of A dot magnitude of B. So magnitude of A dot the magnitude of B. So this one cancel this. I'm left with what? Cos theta is equal to this one here. So at this point here, I will erase this one here. Take this one off. So at this point here, I'll have that cos theta. So I'll have cos theta is equal to this one here. That's the dot product of A and B all over the magnitude of A multiplying the magnitude of B, as in this case. So I want to make theta stand alone. So I have that theta is equal, take this one in, I'll have cos inverse of what's it called, of A dot B, as in this case, right, all over the magnitude of A dot the magnitude of B. So this is mathematical expression when it comes to calculating dot product in terms of angle. So let us idea now to solve some problem. Welcome back. So let's say we are told to solve this problem here. Example 1 says if vector A is equal to 3i plus 4j minus k and vector B is this one here, as you can see, find the dot product of A and B and the angle between vector A and vector B. So how do you solve this problem here? So your first task here now is that solution. Your first task now is to find the dot product of A and B. So the dot product of vector A and vector B will be equal to, we said the idea is that multiply this one with this, multiply this with this, multiply this one with this. So I'm having 3 times 6 plus 4 times 2 plus the coefficient of k here is -1 times 5. So the dot product of this vector becomes 3 times 6 is 18 plus 8 plus into -5. If I simplify this one, I'll have 18 plus 8 plus minus will give -5. If I simplify this one here, that's 18 plus what's it called? 18 plus 8 is 26. 26 minus 5, that will give about 21. So my answer becomes 21 as the dot product of these two vectors. My answer becomes 21 as the dot product of these two vectors. So let's now get the second task done. What second task? Second task says that and find the angle between the vector A and B. We say when it comes to finding the angle, what do we know? We know that theta, recall that we said theta is equal to cos inverse of what? Of vector A dot vector B, right? So all over the magnitude of A, right, dot the magnitude of B, something of this nature, right? So my task now is to get magnitude of A and magnitude of B. So let's get magnitude of A and B. I've gotten dot product as 21. Let's get these two. So get the magnitude of A. What we know is that we say when it comes to getting the magnitude of A, simply take the square root of the coefficient of each term. So for A now, this is 3. I'll have 3 squared plus this is 4. I'll have 4 squared plus into this is -1 all squared. So the magnitude or modulus of vector A is equal 3 squared will give 9 plus 4 squared will give 16. Plus minus is minus, sorry, 1 plus -1 squared will give 1, right, at this point here. So it means that the magnitude of vector A will be equal in value to 9 plus 16 plus 1 is about √26. So I have 26 as my answer to 26. 9 plus 1 is 10. 26. So I have √26 as my answer to this one here as the magnitude of A. Let's get magnitude of B. So the magnitude of B is equal to, we said, take the square root of each coordinate. That's 6 squared. 6 squared plus 2 squared plus 5 squared. At this point here, the magnitude of of B or modulus is equal to the square root of 6 squared, we get 36 plus 4 plus 5. At this point here, I'll have my magnitude to be equal to √45. So that 36 plus 4 will give 40 plus 5. I have 45. So I've got this value now. Let's now get the angle between the two vectors. So I'll have that angle theta is equal to cos inverse of the dot product of A and B is 21. I have 21 all over magnitude of A is √26. √26 dot magnitude of B is √49. I have √45 per se. So I have this one here. So it means that the angle is equal to cos inverse of 21 all over √26. So √26 is about 5.099 multiplied by √49, √45 per se. I'll have 6.708. So the angle is equal to the cos inverse of 21 all over. Multiply these two, so times 5.099. I have 34.205. So at this point here, divide these two here. Theta is equal to cos inverse of, divide 21 by this answer here. I'll have 0.6139. At this point here, I'll take the cos inverse of this value here. Theta now is equal to cos inverse of 0.6139. I'll have 52.13 degrees as the angle between the two vector A and B. All right, I don't understand this one yet. There's one more thing I want to emphasize on. What's the thing? The concept is that if the angle of a dot product is perpendicular, that is equal to 90 degrees, the dot product will be equal to 0. So I'm saying that if two vectors are perpendicular, their dot product is equal to 90 degrees. True or false? True. So if the dot product of or the angle between two vectors is 90 degrees in terms of dot product, hence the dot product is equal to 0. What do I mean? If I have what we know is that the dot product of A and B, right, is equal to, that's the modulus or magnitude of A, magnitude of B, cos theta. And we said theta is equal to 90 degrees if they are what? Perpendicular. So I'm saying that the dot product of A and dot product of B will be equal to the magnitude of A, my magnitude of B, right? So cos theta, that's cos 90. If you press cos 90, I'll have 0. So it means that we're having the dot product of A and dot product of B is equal to the magnitude of A, magnitude of B times 0. So if I multiply 0 by anything, I'll have 0. So the dot product of A and dot product of B is equal to 0. So the idea is that if the angle between two vectors is 90 degrees, it means that their dot product is equal to 0. See you in our next class.